Today we are going to talk about machine learning models. First, we need to see our dataset and what problem do we have. Mainly, we're going to take a look of classification models that are supervised models, and then one of clustering model that's unsupervised one. I mounted the drive. Here you can find the path to your local or your drive that you have. I'm gonna choose now and write pandas with import pandas as PD. I'm gonna import a package from which I'm gonna read. With PD read, now we're gonna read Excel file. I'm gonna copy the path through to my dataset. It's file detection. If we take a look at the dataset, you can see that it has x, y, z, that are some coordinates that come from the sensor. The sensor can be chest, belt, ankle left, ankle right. And our target column is the anomaly. The anomaly is having if I take a look of the anomaly value count, we can see that anomaly is 0 or 1, or here we can say that we are having a binary classification. This means that we are having just two classes that we need to determine. So with the value counts that comes as a functionality from data frames in pandas, you can see how many of the rows or how many instances are zeros and how many are classified as ones. As we can see here, we're having 5,000 approximately zeros and 300 ones. It means that we're having unbalanced data set. This mainly can lead to some models that are not so good. The unbalanced data set means that the model is making some maybe it will have a less good approach than if the data set was balanced one. So firstly, what we need to take a look is the sensor, because as you know, the models in machine learning, as if I open here, we are having a given model. The model is having input statement and is having an output. The input always needs to be a digit number in a given list. Here, the model that we have is, let's say, some mathematic functions, for example, multiplication or linear regression or logistic regression, etc., etc. And with the help of mathematical functionalities, it gives some output. This output that we have, it's based on, it will be made, in our case now, it will be 1 or 0. If the model was some floating numbers, some numbers that are decimal, then we will have here appearing some decimal number as output. As you can see, for a given input, for example, here having 3 different values, we can have binary classification 1 or 0. But as I said, we need firstly to make input of numerical values. Because of that, this sensor here is our main problem. Now, let's take a look for the first sensor, value counts. We're having ankle, belt, chest, and ankle right. For labeling this column, we're going to use from sklearn. In the pre-processing part, we are having importing a label encoder. With the help of label encoder, each of these values will have integer starting from 0 till here till 3, and it will be like a dictionary. For ankle left, it will change the value to 0, for belt to 1, etc., etc. Now let's create instance for label encoder, just empty constructor, and call it to fit on the data. How we call for the sensor? We are calling fit transform. With what means fit transform? Fit means that we are fitting the model. The model learns the data, makes some dictionary. The dictionary says, okay, chest will be 0, ankle will be 1, ankle left 1, ankle right 2, and belt 3. Then this dictionary is transformed, is make mapping directly into the input. The input is given in the argument. Now, if we take a look of the dataset, you can see that these sensors are now integer numbers. If we want to take and say which index and go back propagation, how are these mapped? For the index of the list is the number appearing and that's mapped right in the column. So ankle left is 0 value, ankle right 0, 1 is 1 value, belt is value 2, and chest is with value 3. The next statement that we need to make, like for the pre-processing part, is to scale the values. Now the part of scaling. The scaling part is based on numeric values. You're having different types of scaling. We're going to take a look of min-max scaler from sklearn library. Let's take a look of different scalars. So one of the scalars is standard scalar. This is making normalization using the mean and standard deviation on each of the values. If we take a look of min max scalar, we're opening the documentation here. With the help of x minimum and x maximum, we can make normalization. This here normalization, all the values that are scaled are in the bound from 0 till 1. 1 is the number of the maximum value in the column and 0 for the minimum value in the data. Now, we are going to use min-max scalar. You can use any scalar that you want. Sklearn, preprocessing. We are importing the min-max scalar. Let's take scalar. Let's take instance from the scalar and then transform the data. So first transform x data from scalar fit transform x data. So now you can see that array reshape we need something that's 2 dimensions. Because of that, we're gonna make here iloc. Let's take a look of what iloc do. Iloc takes here all the values. This first part on the left before the point is for the rows, and the second one is for the columns. Here we're telling which column to be taken. If we want the first column is from 0 till 1, not taking the first column. So here we are having x like a data frame. If we take the fx like this, here we are having just a series of pandas. So we're going to use iloc as a function for giving us 2-dimensional array. Now I need each time to call min-max scalar, because with the fit transform on each epsilon z, it will make training like it's not a retraining, it's like just uploading the already trained data on the scaler. So I'm gonna call this for epsilon, that's the first column. Oh, sorry, my mistake. I'm gonna rerun this code. Okay, now here it needs to be epsilon, I missed it on x, and now for z, 2 till 3, not taking the third column. If we take a look of Diffie now, you can see that here the values are, as you can see, I didn't write here z, and the z values are not scaled as good as, are not scaled already. Now let's, another time, let's run all the code that we have written. Okay, now as you can see, x, epsilon, z are having values from 0 to 1. The next part, let's make some data visualization that will help us. Data visualization that will help us to have a more specific image, more, I will say, global image of the whole data set, so we can know when we build the models, is it the model bet or is it the data set giving some values that are not good based on its features. We need firstly to know the features that our data set has. So from the anomaly, we're gonna first make a group value count. Let's make a value count. And with this value count, we are having for 0 and 1. We are gonna plot them with the help of plot bar. That's part of the pandas data frame, plotting a bar plot. This bar plot is just concatenating, summarizing the values and importing it as some cylinders, as you can see. Now, it's obvious that the data set is very, very unbalanced. Let's take a look. Does the data set have some non-values? How we calculate the missing values from the data set is null. Let's take a look first of this part. Is now from the pandas gives us false or true. True gives us on the places on the cells where we are having none as a value. None, it means that that cell is an empty cell if you open it on Excel. Now if we make sum, it will sum up all the non-values in each column. This I'm gonna import in the missing values buffer. Let's calculate the percentage of this data frame of these values. Is now, let's make summarization that we have, and we are dividing that number with whole length of the data frame. Now if you want to make a table from this, we're gonna take a missing values table, and it will be a concatenation. With the help of PD concat, we are concatenating two data frames from the missing values and the percentage buffer. We are concatenating by axis 1. It means that we are concatenating columns. If it's axis 0, we are concatenating rows. Now, missing values we can add a table. Now, table. We can add columns. In the columns, we can say here number of missing values and the percent of missing values. We take a look of the table. Here there are, for each one, we are having 0 as a value. So here in this data set, we don't have missing values. That's the good part. So we don't need to handle missing values. Some other course for Python in our platform, you can see how we handle missing values. Now, the next part is to see how what are the features, how the data set behaves. So let's take a look of group by. Group by is like in SQL, you're having groupation of instances by some feature. We're gonna first group by sensor and then with together with the anomaly. This will give us an object of group by, which needs to be added some function. We're going to count the instances of each group by. As you can see, for each sensor anomaly pair 0, 0, 0, 1, 0, 1, 1, 1. So each has its pair. It's calculated x, y, and z. You can see that x, y, and z are having same values. It's because this count is given, it calculates rows, how many rows are 0, 0, how many are 0, 1, and for x, y, and z, they are all the same. If I just select one of the columns, you can see the numbers of each instance, how many rows are 0, 0 classified. Now, if we make reset index, this will take the model into a data frame. Let's say that this is DS data frame. For this data frame, I'm gonna take new names for the columns. It will be sensor, same anomaly. At the end, let's make count. How we plot it? For the plot, for the visualization in Python, let's take a look at the DS perspective. We're having now count as a new name of x value, of x column. For the visualization part in Python, there are really a bunch of packages that you can use. I think that Plotly is now in the dashboard, the Dashly. It's really it's having some advantages and it's really advanced. It's using SCSS and Vue in the background. So it's implementing functionalities of statistic like histograms, box plot, bar plot, etc. And it makes to be interactive. You can either create your own dashboard, then post it online and make it a web app. Either you can call it in a Jupyter notebook, and it can be really interactive. We can see one example. If we want to import a plotly express as px, we are creating a figure of plotly express. Now we are calling a bar plot. In the bar plot, first, it's the data. Data frame, in our case, is the cell where we are having the sensor anomaly value and the count of instances. Now in X, we're gonna call sensor data. From it's called in X is the DS sensor that we have. In Y, the count data. And as a color, how the cylinders will be alert, we are going to say that's anomaly because it's the class and it has either 0 or 1 as a value. We can add orientation, V, title, orientation V for vertical orientation, count of anomalies per sensor. The next is the width and height of the data. So let's take 700s and 800s. At the end, we need to make fig dot show for showing and plotting the figure. As you can see, the blue ones are zeros. The one is here. The one is yellow. As you can see here, is given how many counts, what is the number of sensor, what's the anomaly, and gives the value of it. You can see that for the sensors, the data for zeros, it's more often coming up, and the anomaly is less frequent. What we want to see is, does the x, y, and z having some intercorrelations. So we are importing Seaborn as soon as it's library for mainly for plotting. With the help of heat map, we are gonna make um, metrics where it will give us the weights of the correlation between each values. With the help of correlate function, you can see that on x on rows and columns we are having same values, and here is calculated the correlation between them, or how the values what is the relationship, how big is the relationship between two columns. So between two x values, for x and x, the value is 1, is the maximum value because it's the same column. For x and y, we are having in minus. It means that these two columns are not correlated. They are negatively correlated. It means that they don't came up with any similarities between them. So in SNS, we're going to implement this heat map, the correlation function, and say annotation to be a true value. Let's take a look. Now you can see that this is colored by from minus 0.6 till 1. We are having values, 1 only for the same columns, and the maximum correlation is 0.29. That's small correlation. The maximum needs to be 1. But as you can see, these columns are not good. They are not correlated. Also from SNS, we can call a pair plot for our data set. This may take a while, but we're gonna wait. Okay. Now, as you can see here, the data is not taking any function. Maybe this x and z and y and z is making some like, I will say, some cubic or some not so linear, maybe a polynomial function, but the data is not good correlated. There are random data appearing up. So the next step, let's make a 3D visualization of our x, y, z based on the anomaly. From the import of Plotly Express, as we already implemented, Express. Now we are gonna take the figure and make a scatter that's 3D. Here, the data frame that we are using on X, the X values, on Y, the Y column, on Z, the Z column, and as color, we are gonna use the anomaly. Here I'm gonna add size maximum of the dots that will appear, the points that we're having. Now, figure, show, and with this, here we are having the values. As you can see, For each point, you can zoom and zoom out. You can either turn on the graph into all three dimensions. You can see that the branches that we are having for once are like separated and are grouped by, are centralized together. The bias is small, so the values are very closely to each other, and I think the kind of classification will really work out for this data set. Let's take a look. We're going to take a look for each model specifically, and you can see that some models that are more complex will make maybe worse results than the ones that are really, really simple and are just mathematically used one. So here is how the anomaly is colored and how the dots in three-dimensional space are based. So here, it's visually you can see how each x, y, and z in the dataset is represented in a given area. So each point is having a features. Here there are the x, y, and z values that are gotten from the sensor itself. Anomaly, it's the color, and you can see in the space how the values are having each own feature, how they're grouped by, how is their derivation, etc., etc. The next one, it's the same scatter, but we're gonna use coloring in sensor. Let's show the data. Now you can see that the sensor data are not grouped by, are not separated. If we zoom it up, you can see that for each sensor there are values that are one on top to another, and they are all in a given space. As you can see, for z, x, and y, the values are from 0 to 1. That means that the values are normalized when min max scalar. With this part, we mainly focused on pre-processing and data visualization of our features. I'll go to the next video for seeing the first and the base model of